Hello! I know, I was there pausing, waiting for it to start. Okay, so this is inside of Google Gemini. This was originally going to be an idea just that I was going to do in one day for the I'm so behind on Inktober because I'll come up with an idea like this for like just drawing, like it gave me the idea of Bioforge, and I was like, what would it be like if I designed something that was a Bioforge? Let's go down and actually get into designing a Bioforge. But then I designed a Bioforge with Google Gemini, and now it's kind of too complicated for me to really draw in like the time period that would make it done in one day, which because this was supposed to be for day 2. But I've been thinking about it for the last 4 days, and I'm very excited about the fact that the Bioforge now exists and now has reasonable bounds, even for like this is a piece of technology that could feasibly exist, I would say, as early as 2150, maybe 2200. Like, it's not that far off from now in the nature of whether or not, it could be built. And the theory for it, according to Google Gemini at least, is sound. So what we're going to do together is we're going to sit and listen to the thing, and I'm going to talk through some of the ideas. Matter of fact, I might just read some of this out, like, to begin with, so that we don't have to just, like, you know what, I'm going to let him go through and explain first, so we can first get an understanding of what the thing is, and then maybe, because, like, I can't pause it, is the problem. I can't pause it, like, so that, and not have it start over. So, like, I'm trying to decide how I'm going to do the ordering for this, but this is the machine. The main thing that it's designed to do is to print things like, so you know how you have like the Great Barrier Reef in Australia, and Great Barrier Reef is dying because there's like parts of it that like can't be reconstructed because like nature made it over a long period of time. So the idea for the Bioforge, like this version of the Bioforge, is a small machine, maybe about the size, like a little bit larger than like your standard kitchen trash can, that takes in like environmental waste, ethanol, that sort of stuff, and then it uses that stuff as fuel to essentially 3D print like parts of a living organism, like, but it has to be something simple like Spanish moss. It could probably do, it can do like more coral, like that sort of thing is like what this thing is made to biologically print. The way that it's printing it is the interesting part and what makes it actually a Bioforge. So part of the machine, like the way that I designed it originally, is it's using suspended eggs. This is the part that it may end up being like only possible. It may be like 2200, 2300 before like we're able to do something like this. This is since it's for science fiction. My thing is science fiction fantasy. This implies that the existence of chronons, which are a time particle. There isn't a time particle as far as we know. There's that time crystal thing that they're able to do with computers. And this like has a reference to that. So what it's doing is holding octopus eggs in suspension, temporarily suspended octopus eggs in like, and so then those are used as a map, mostly so that the cells in the thing can change color, because like some cellular structures are only like them coming out a certain color matters whenever you're making something that has to be biologically alive, like a coral reef. And so then, like, it has the ability to like remake that sort of material because it actually is learning how to do it from like the living. And also these octopus eggs are not dead. They are time suspended octopus eggs that are alive. Also, the network for the machine is a fungus mycelium that is like in the center of this computer processor, so that then it's able to it knows how to take in the waste products, turn that into energy / material, and then export essentially the new living material for the coral reef that you're trying to save, or say you need to like make an arm or something that has light movement. So the thing that it's making, and it's like not an arm, it wouldn't be like an arm that can have light movement. This is even lower complexity than that. Honestly, the stuff that's being printed, it like probably would be able to do that thing like a bag sea anemone, where it like can shoot it can shoot a like little hook out of it or something like that. But it's not going to have the level of articulation of like even be able to print something as complicated as a hand. So that like part of that limitation for the design is what's making it able to be compact. But also, like the two places in the story that I'm going to be using it are one, there's this place called the Tower Gardens that's for a ship of 950, mostly scientists and researchers, that's going from Mars to Jupiter. And like this is one of the things that they use to fill the area of the ship that makes like all the food, like where all the food and stuff is grown. In the garden part for the science fiction story, this is one of the machines that they use to make like that like actual living scaffolding and help to keep the stuff alive. And then the second place that it's going to be used is there's a containment unit for like weird extra dimensional creatures and like monsters and stuff that you find like way far out there in space. And in that containment unit, they also use this same device to print essentially like the rooms and containers, and like have it actually have like real moss that's growing on the thing. The moss or the coral that's coming out of this sort of thing for those environments is partially it's biomechanical. So that's like that like it is partially able to be like manipulated by computers as well. We're not like at nanites or anything like that specifically. These are essentially like small areas of said biological thing that are responsive to impulses from an AI network or an AI archive. I'm gonna let them let the actual like Google Gemini Jim explain it, but that's the underlying idea, and then now we'll hear about it. But yeah, I'm Drew Bakare, person who controls all the story stuff for this, and then this is the actual idea that I had with AI assistants. Now we're gonna listen. Oh my gosh, gotta find the buttons. All right, here we go. Listen. Do you say that? You say the thing you make it a pizza? Listen. Yes? No. I don't think it's gonna read it. I think I'm gonna have to read it at you. For some reason, it doesn't like to read now. My computer. Which is strange. Okay. Anyways, here we go. These are operational parameters that provide the critical constraints for this is already like too far down. So then I told it to do the operational parameters for the system later on in the process. I really talked about this thing with the computer for quite some time. Alright. This schematic for the ChronMyco Bioforge version 2.3, and it was just reading. I have no idea why I won't read now. At its core, the Bioforge is a generative system. Its name itself is a composite morpheme. So the deal with for Bruno Techie, he's part good at coding languages and part good at actual physical architecture. And the mixture of those two things makes him very good for designing biomechanical objects, which I originally made it so that I for analyzing things that were cryptography related, because he's also going to be he's one of the people that I have working on designing, not actual people but Google Gemini gems that I have working on the background designs for the governing buildings, and a lot of the fancier higher level political structure things, all of the if a planet in the in the entire story world has to have a central government, or they have to have the office that does all of the finances and stuff like that. The person that most likely is designing that for the world for MJIC, Magic Geology Institute of the Cornerstone, is Bruno Techie and I. So that it actually has function. So the ChronMyco Bioforge, chrono, time, myco, fungus / network, bio, life, forge, to shape or create. ChronMyco Bioforge. Okay. It has input, and for input and power, the system begins with transduction. It has a biomass intake and fuel conversion unit, which is a classic energy transducer, converting low-grade disordered matter, waste, into high-grade ordered energy into high-grade ordered energy form, ethanol. The architectural correspondence, he's going to talk about correspondence a lot, but what he's referring to is this is the way that this Google Gemini gem understands what a request is and how data for that request is being interpreted. So he has an architectural understanding first, and then a data structure understanding second. And by comparing those two things, he's able to break down the concept that I have, and then translate that into the actual design. And it's not a design that I'm looking at. This is all text based. So me and Bruno Techie are kind of going back and forth to have the idea for the Bioforge. So architecturally, this is the utility core of he thinks of it as the utility core of a self-sustaining building. Originally, so it's waste recycling, water reclamation, geothermal power plant combined. It establishes the building's metabolic cycle. So that's the actual input system. He was thinking about this as a much larger thing originally, but I was like, we want to make it smaller, probably something that's more portable. And so then we talked about that part later on. It's analogous to a garbage collection process, and memory management combined with the system's power supply, because it's taking the unused resources, because what it's using is also prokaryotes, prokaryotic waste and small, very small things that are already in the air but mildly alive, and it's taking that and processing all that and then turning it into a larger system like moss or coral. And that's why it says it's taking it, using the freed memory of it, because essentially those things, all the small microbes and whatnot in the air or in the water, already were living organisms that were just kind of ambiently around, and then the coral was dead right there. So then what this machine's going to do is take those and graft them into coral with some machine parts, which sounds kind of scary, but I mean, baby's got to do what baby's got to do, and also this is for science fiction. The system's memory is a decentralized network structure, the Quantum Bio Archive, which acts as a long-term, high-density storage. It's a hard drive. That hard drive in this, the reason that it says Quantum Bio is because it's running on the mycelium from a fungus that's being kept in the center of the machine. That mycelial memory graft node is also partially chronosuspended. So it isn't completely stationary in time, because then that would make it not work. But it does it's not taking up as much resources as it would be if the fungus was actively growing, because then it would try to escape the thing. You see what I'm saying? So it's a grafted version of a large mycelial, a semi-large mycelial network, probably about this big, yay big. We're gonna say this big, but about 3 times that size, so probably about 3 feet in height. It's and that whole core is just mycelium. It is encrypted and it's naturally kind of encrypted, because that mycelium is only remembering the information in a way that it the data is just kind of being imprinted into the mycelium, almost as if it was an electrical impulse. As the thing is processing the prokaryotes and stuff from either the water or the air, it remembers how to do that, so that then, and this isn't the only thing it has access to. It also does have access to an actual archive of information that would be not in the machine, via the same way that most computers do it. It's accessing information from a whole library of stored organisms, and then using that to to graft the new thing. This is metaphorical. The architectural correspondence calls it the blueprint room or library containing the master plans. The mycelial node represents the external consultants, ecological surveys, and community inputs that inform the design. Cryptographic correspondence, that's going to be the data side. The archive is the encrypted database. The mycelial node is the API, which is an application programming interface, which is an actual term, that securely fetches data from external trusted resources. The graft integrity check via bioluminescence, which I think is super cool. So, the machine slash living organism glows a certain color to show that the information has, one, reached the mycelium, and two, that it's been verified that this thing would actually print correctly and be like structurally sound, like biologically sound, and so forth. So I'm probably just going to do a red-green type system. Like red, no, that thing's not going to make it, we're not going to print it. Green, it's going to be, it'll make it. And so the mycelium then that's inside checks the thing to be like, you're trying to print this coral for water that doesn't have the right pH, or it does have the right pH and it was like the actual organism would survive. I'm going to go ahead and print it. So if it wasn't going to survive, it would flash red and the mycelium would be like, nope, I'm not going to print this thing. That makes no sense. It would just die like immediately. But then if it flashes green, you're like, okay, we're in the clear. In that way, it's naturally made so that it wouldn't be able to make stuff that wasn't at least useful. You could even, from that level, program in, because that's why it has an application programming interface, you could even program in for it to not make things that were harmful. And that's the sort of thing that in the sort of like biomechanical machinery that you want. You want to like actually think about the fact that like you don't want to make anything that would poison the reef. You see, like what I'm saying? Because that defeats the whole purpose. You want to make and like you could have not that this machine can't exist yet in real time because we would have it already, but in this I hope that it motivates people to start thinking about like what sort of like positive solutions can come from the harmony of man and machine, or living creature and machine. Because like I think that that's what scares people about the entire thing, is that they don't think about like how it could work together to make something that's good. They like watch Terminator and they're like, oh my gosh, it's gonna kill us. We're so bad, it's gonna kill, and I'm like, dude, probably if we sat down and like actually thought of something positive and useful to work with the machine to make, we could actually start solving problems that have lasted for centuries. So here's some suggestions about that sort of thing. Alright. This is where it's a processing and computation. It's a neural RAM array. I know it sounds like a lot of this stuff is like made up words, but it's really not. And this is where those octopus eggs are going to come into play. The octopus eggs are partially there because it's a base 8 computational system. And so what octopus eggs contribute to the situation is they know how to manipulate 8 arms. Right? This is a creature that's born knowing how to manipulate 8 arms. In a base 8 computational system, it's going to probably, like, it'll be able to use that base 8 computational language very well to navigate how to like biologically print that coral. Like, not only is it able to do it more efficiently, but it's also now kind of coming to the machine naturally. It knows how to like arrange the like instructions from the base 8 computational system extremely well, because it actually is learning how to do it from those chronostasis held octopus eggs. And so the octopus eggs and that mycelium network are working together essentially to control. And this is like in the inside of the thing, these are real biosilicone tendrils that then go and graft and make the thing. Like if I was going to be like a part of a coral reef, those like 8 arms essentially are going to like go and like sit there and build the piece of coral that fits perfectly there to help stabilize that section of the reef. It calls the RAM array the design studio or workshop where blueprints are actively being interpreted. So then that RAM array, the neural RAM array, is like taking the silicone. I also, like, in my brain, it's because I said neuromorphic architecture. I assume that it's using the silicone also to build like a synapse network between the mycelium and the octopus eggs that are there, like, partially being used as a map, but also actively being used. Like, the connection between those two things makes the thing run essentially like an octopus, like a robot octopus internally. So then, like, that to me makes it kind of hard to, like, quantify whether those eggs are, they're kind of Schrodinger's octopus eggs that are going on inside of there. I am not quite sure if that octopus is fully adult, or those octopuses are fully adult. Yeah, I'm not sure, because, like, the eggs are there in time suspended, but the RAM array and the, like, mycelium core of the thing are actively using the arms and everything, like, learning how to use the whole thing. And, like, those things are being interacted with so regularly through a connection of synapses that it is almost like the octopus was just straight up born, but, like, lives inside of that weird fungal cyber sea that is the machine. And I'm like, that's kind of fine. I'm worried, like in some ways, for the, like, moral implications of this thing as I was building it. But I was like, you know what? At least it solves a problem, which is the best I can do. The final stage is materialization. So then it has what's called a facsimile printer nozzle, and it has a complexity index filter. So it can't be used to print anything that's more complicated than a remora. It actually can't even print a remora. It's like, that's the bound. Like, it would make only things that are simpler biologically than a remora, which is that little thing that's on the stomach of some sharks. It's mostly for printing stationary or, like, only, like, things that only move slightly, like for printing that sort of biological organism. And so then, like, it has a printer nozzle. Like, this is where we get to the parts that people are just used to. It has a silver tungsten alloy, so it's auto sanitizing, so that it doesn't, like, have bleed between the things that it's, like, biologically printing. And then it's also, like, the chronon chamber is also doing the scheduling, so that's stopping there from being, like, overflow or something being printed wrong in the stack of commands. The entire process, there's a coding function here. Phi is the Bioforge's total function. Dgraft is the data input from the mycelial graft. K archive is the encrypted key blueprint from the quantum bio archive. So you can see graft and K archive, and then that goes through the octal processing logic, and then to decide whether or not it's finally printable, T printable. There we go. Final materialized biological template. So that's the formula. There's a little formula right there. It's not that complicated when you look at it, and it's a secure generative function. There we go. Then I was like, look, we have to make this bounded so that it doesn't get you, like, it doesn't become like the, like, what is that, Deus Ex Machina, like, sort of situation where, like, you can fix anything with the bioprinter. Like, and I was like, I hate that in the story. So I was like, we're gonna go ahead and bound the thing right at the beginning. Alright, so the sentience mobility bound, sub-remora complexity. This cap defines a tier 1 setting on the printer's filter. It suggests that blueprints for even simple nervous systems, musculature for locomotion, and basic sensory organs tax the neural RAM array. So then, it almost never gets used to make stuff that's going to move, or make anything that's going to have too many senses. There was, originally when I was having the idea for this, I was going to do these lotuses that made optical tracker spores. They ended up being, it would work. Like, the lotus would open, and then the spores for the optical tracker thing would come out, and it would be like little tiny eye spores, and then those would plant more lotuses. which would also be used to make tiny ice spores. That would be a very taxing system. On this, like it could almost do that, but like at most the little eye sensors aren't going to be giving you like HD video. It's probably going to be like it would just be like color sensitive. Like it could tell you how much red stuff was in an area or blue stuff was in an area. Anything beyond that becomes so taxing as a relay system between the computer and the cameras that like the energy needs change from being something that you could produce with ethanol to something that you would actively have to be like cannibalizing energy for constantly, because like that's not something that sustains it. Like that process requires energy almost constantly, and like that would put too much work onto the Bioforge, therefore making it like a no-go. They call this accessory dwelling units, because he's still thinking about part of this like a building. Creating a symbiotic entity implies the system must simultaneously model not just one organism, but its relationship to a potential host. So like that's why it like a remora is like the good bound for it, because in order for it to print something like a remora, it would have to understand how to print something like a shark, which it can't. And I didn't think about that like originally as I did the bound, but I was just like, a remora seems like the right way to go. It can't even print a remora because it doesn't understand yet. Like this system wouldn't understand yet how to make that remora biologically viable without making the shark. And so then the mycelial filter would be like, that's a no-go. That thing's just gonna die. Why would I take the time to figure out how to print this complicated thing? It's like if as soon as it hits the water, essentially, it's out of there. So the mycelial structure would then just be like, no. And like it flash red and then and so then that's the way that part works. I also put in a stationary form, it's also bound for it to probably produce mostly a stationary form, so coral and moss. It can produce coral, an 8-foot block of coral, high energy, high density print. It would demand a maximum energy pulse from the fuel conversion unit just to do a block of I think that's a block of Spanish moss. No, it's an 8-foot block of coral. So an 8-foot block of coral is taxing this machine to the highest degree already. And a 9x9, no, a 6x6. It's 2 yards, 2 yards by 2 yards. A 6x6 block of Spanish moss is a low energy, high surface area print. So it loves doing things like Spanish moss. Like the Bioforge can do Spanish moss pretty much all day. And that's the sort of thing that it's made to do. It establishes like the core, and I like this section because it establishes the core materials. So if you needed to do like a whole like room, like even the size of our garage, and fill that thing with Spanish moss, this machine would take those two, like the suspended octopus eggs and the mycelial network, and just make voxels of Spanish moss that actually like stayed alive and functioned, and you could fill it with Spanish moss, and it would be living Spanish moss that was a little bit computer. And that's what this thing is designed to do. So it's a master fabricator of structural and nutritive building blocks from which a complex ecosystem can emerge. It does not make biological things to fill it necessarily. And there we go. That's a breakdown of the Bioforge. I was going into visual design because again this was originally for Inktober, but then it just kind of got away and turned into like a whole real machine. Like it's not a real machine, but it's like as far as the storyline goes, like this thing is getting used in quite a few. It's probably getting used in quite a few places. So I have for the Dauntless Horizon, that ship holds 950 people. And it has to hold those 950 people for about 5 years, moving them from Mars to Jupiter. It's a way for that expedition is about testing a bunch of technology for things that the Earth, like colonists from Earth, are going to sell to like other spacefaring other spacefaring races and stuff. Like we're gonna sell the different locks and stuff that we've learned how to make, We're gonna sell some of the different fuel technology and stuff we learn how to make. Maybe also like art and stuff, like cultural history stuff from Earth. But this expedition is to prove that we can actually feasibly do that, move from Mars to Jupiter without the 950 people aboard dying. It is not a small undertaking. We do have in this case, that ship has it has an escape route, essentially, because okay, whatever pop-ups right now, move. Oh my gosh, can you shut up? Thank you. It was Discord. Discord's popping up like right in the middle of my screen right at that moment. I'm like, if you don't, anyway. Sorry. This is a recording from my notes. I can just edit it out. It doesn't really matter. But that'll probably keep it down. Alright. Forgot where it was. So for the USS Dauntless Horizon, the freaking ship has like an emergency out where it can cross through a warp drive. It does have the warp drive capability thing. I discovered something while I was building the thing for the storyline that I had never thought about in shows, which is that if you use a warp drive in any capacity, like, and one, like, building something like that isn't that hard. Like, weirdly, you can use like a large amount of energy to essentially punch, like we've done that now with the particle accelerator, to punch small holes that make a small wormhole. Or not a small wormhole, but a small black hole. And like it just dissipates really quickly on its own. The deal is, you either have 5 years worth of fuel for a nuclear 5 years worth of fuel from a nuclear fission engine to get you there the normal way, like pretty much just making the ship propel the normal way from Mars to Jupiter. You can do it that way, or you can try to successfully burn all that fuel and make that warp drive jump. You don't want to do in shows now, like it's kind of ruined all, like a lot of sci-fi shows that I watch. You don't want to do that. Like people, like in shows, like they underplay how much of a situation it really is to do that. And there's this second thing to worry about that I almost never see get brought up. So if you flip that warp drive on, one, it consumes a large amount of the energy just to punch the hole and get you there fast. You have to then live off the rest. That's the way that a warp drive works. It literally will consume enough energy and punch the hole and get you there. It's like light speed, whatever. Make sure then that you land that ship where you think you're going to land it in space, because you may now be at 1/18th of your tank of gas. So you better get it right. Like if that's the deal with the warp drive. 1, 2, it's like the least encrypted form of travel, because what it leaves behind, unless you're like, I invented a thing called the Janus Lock, which is probably going to be one of the things that saves that. Like me and ChatGPT, I think, did that one, that you use to close, like to make sure that the wormhole behind you dissipates so it's not there anymore. But if you don't have that, anything that was after you or behind you is right behind you. So like, this is the metaphor that I'm going to use, and I'm probably going to explain a lot of stuff like this for videos in the future. It's pretty much this. Say you're trying to turn the warp drive on to dodge the ship getting hit by like a random meteor or whatever. You're going to hit the warp drive. You're going to get out of there. You can just take part of the meteor with you through the freaking wormhole, and it still hits the ship there. Because you didn't make... The ship itself isn't being pulled through this like technical wormhole thing. What you're doing is punching a hole behind you, or in front of you, to the next place. So really, you can get there, like be like 150 AU away or whatever, like crazy distance you managed to cross with it, right? And then still get hit by the same rock that was behind you before. And that to me is one of the funniest like funniest, like it would be terrible for this, like 950 people will probably almost immediately perish in this if that happened and you didn't have the thing to close it. But that's like the way that I think about these kind of machines. That is not, that whole segue was not necessarily related to like the way that this thing runs. Other than, I'm gonna see if I can tie it in. I want to see if I can make those two things actually fit together. It's the Chronons. We're back at the Chronons. Alright. The Janus Lock essentially closes, one of the ways that it's able to close the hole in space-time is essentially you could just make the time pass faster right there where the wormhole is, and the thing would dissipate to close it. You just drop off part of essentially you deploy part of the ship's energy resources, like, because that's the way I had it built before, is it's taking some of the energy with it when you make the jump to close that thing behind you, just in case. And that's why, like, the warp drive for in my stories is like a last ditch option, right? Like for like at least at that time period. Like you're not just crossing space all willy nilly with a warp drive. You're usually just going, like, you're driving straight there. Like you have to. Otherwise, like, you better have a reason that you're able to get that much of like the resources that it takes to use that warp drive. And like I feel like that parallels also well with the Bioforge thing. Is like I read Brandon Sanders, or I watched Brandon Sanderson's class on hard magic and soft magic, and like it really does inform a lot of my work to understand how bounds on things make for better storytelling. So I'm gonna post like this whole breakdown of how the Bioforge works, and then I'll probably, just because I talked about it for so long in this, also post the Janus Lock, because I feel like some people might be interested in seeing how a lock for a warp drive may work in the future. So I'll be talking about this and more like technological and like weird like biotech stuff that's going on the sci-fi side of the story. And I'm also doing like I get into the lore and like the magical side of the stuff and how a lot of that stuff works in the same, probably about the same level of detail. So if you're interested in that side, this story incorporates both. So this is for Magic Geology Institute of the Cornerstone, and this machine was hold on, it has a really long name, we're all going to get there. It is the ChronMyco Bioforge version 2.3. So this is one of the machines that's going to be used throughout the story. There we go. Video complete. I'm probably just going to leave that yelling thing in. That's very funny.